Hello friends, in this lecture we will study basic terminologies that are used in theory of computation. Basic terminology. Basic terminology. First is alphabet. It is denoted by sigma. What is alphabet? Any finite non-empty set of symbols. Any finite non-empty set of symbols is known as alphabet. Clear? Any finite non-empty set of symbols. For example, A comma B, 0 comma 1, 0, 1, 2, dash 9. Any finite non-empty set of symbols is known as alphabet. Next, what is a string? What is a string? A string is any sequence of 0 or more symbols. Clear? Next, second definition. A string is a finite sequence of symbols over the given alphabet. A string is a finite sequence of symbols over the given alphabet is known as a string. Clear? A string is any finite sequence of 0 or more symbols over the given alphabet. For example, sigma is AB, then A triple B is a string. Clear? Next is empty string. It is denoted by epsilon, or some books it is denoted by lambda. In some books it is denoted by lambda, in some books it is denoted by epsilon. What is empty string? Empty string is a string with 0 number, zero number of symbols. symbols in the sequence of string, also known as null string, also called null string. Null string. It is denoted by epsilon or lambda. Clear? Clear? Next, length of the string. Length of string. Length of string. What is the length of the string? The number of symbols, the number of symbols in the sequence of given string is called length of the string. For example, TOC, the length of the TOC is mod TOC equal to 3. Length of epsilon 0. Length of ABB over the given alphabet A comma B is 3. Then this is the length of the string. What is the length of the string? Number of symbols present in the string. Number of symbols present in the string is known as length of the string. Next is substring. What is substring? Any consecutive sequence of symbols over the given alphabet. Any consecutive sequence of symbols of a string over the given alphabet. Substring. This is asked in 3 or 4 times in GATE examination. Substring. Any consecutive sequence of symbols over the given string. For example, TOC. The substrings of TOC are epsilon, T, O, C, TO, OC, TOC. These are the substrings of TOC. Number of substrings. How many number of substrings for TOC? 7. The generalization for this is note. If the length of the string is n, if the length of the string is n, then the maximum number of substrings including null string or epsilon equal to n into n plus 1 divided by 2. n into n plus divided by 2 plus 1 including epsilon. If we exclude the epsilon or null string, then the number of substrings, maximum number of substrings are n into n plus 1 divided by 2. n into n plus 1 divided by 2. Check TOC. The length of the string is 3. 3 into 3 plus 1 divided by 2 plus 1. 4 into 3, 12. 12 divided by 2, 6. 6 plus 1, 7. Including epsilon. These are the number of substrings. But this generalization is used when string contain only different symbols. This is the maximum number of substrings. For example, if we have string is A double B, then find out the number of find out the number of substring. If we find the number of substring, by default epsilon is included. If we find number of substring using this general formula, then the number of substring is 7. But this is not true. Maximum number of substring is 7, but there are some repetition. For example, epsilon A, AB, BB, A double B, B and B. B is repeated 2 times. So we consider only one B. This is not considerable. Then the number of strings is 3, 4, 5, 6, not 7. Maximum number of strings are 7. This is repeated 2 times. We consider only one. Is it clear? Very good. Next, prefix. Prefix of a string. Trivial. First we consider trivial substring. Trivial substring. Suppose we have a string W, then string W itself and epsilon is called the trivial substring. Trivial substring. Trivial substring always two. String itself and epsilon. String itself and null string. Clear? What is trivial substring? If we have a string, W, then W itself and epsilon means null string is called trivial substrings. Clear? Note. Trivial substring is always 2. Always 2. String itself and epsilon. Next, non-trivial substring. Other than the string itself and null string is called non-trivial substring. Other than the string itself and epsilon is called non-trivial substrings. Is it clear? Non-trivial substrings. Now, prefix. Next is prefix. What is prefix? Any leading symbols, any sequence of leading symbols over the given string. Any sequence of leading symbols over the given string. Any sequence of leading symbols over the given string. Is called prefix of a string. For example, our string is Yadu. Then the number of prefixes epsilon, Y, YA, YAD, YAD. These are the prefix of this string. These are the prefix of this string. Clear? Note. If the length of the string is n, then the number of prefix of a string equal to n plus 1. Check, the length of the string is 4, then the number of prefixes are 5. Clear? Very good. Next, suffix. Suffix of a string. Suffix of a string. Any sequence of trailing symbols. Over the given string. Any sequence of trailing symbols over the given string is called suffix of a string. Suffix of a string. Clear? For example, Yadu. Then suffix क्या होगा? What is suffix? U, DU, ADU, YADU and epsilon. Note, if the length of the string is n, if the length of the string is n, then the number of suffix for a string equal to n plus 1. Clear? Next is power of an alphabet. Power of an alphabet. Consider sigma equal to a comma b, the following are powers of an alphabet, over input alphabet. What do you mean by this? Suppose power of sigma is 0. It means how many number of symbols of length 0? How many number of strings for length 0? For length 0. Only one. Only one. Only one. Which is epsilon. What do you mean by the power of 1? Means number of strings for length 1. Number of strings for length 1. A comma B. The number of strings equal to 2 की power 1. This is 2 की power 0. Yes or no? Where 2 is the number of alphabet in input symbols. Number of symbols in the alphabet. In the number of symbols, where 2 is the number of symbols in the input alphabet. Clear? What do you mean by the sigma की power 2? This is also written as, it means AB equal to AA, AB, BA, BB. The length of the string is 2 and the number of strings for length 2 is number of strings for length 2 is 2 की power 2. Is it clear? Is it clear? Clear? What do you mean by this? It is also written as then the number of strings of length 3, number of strings for length 3 is 2 की power 3 and so on. Sigma की power n. The number of strings for length n is 2 की power n, where 2 is the number of symbols in the input alphabet. Clear? Can we generalize this? Yes, we can generalize this. Note, if input alphabet is sigma, then the number of strings of length n is mod of sigma की power n, mod of sigma की power n. Is it clear to you? Is it clear to you? Please check this. Please check this. Please check. Next, clean star closure. Clean star closure. What do you mean by the clean star closure? Clean star closure. Clean star closure. It is denoted by sigma की power star. It is the set of all strings over the given alphabet, including epsilon. What do you mean by the clean closure? It is the set of all strings over the given alphabet, including null string or epsilon. Including epsilon. Including epsilon. For example, sigma equal to a comma b. Then what is sigma star? Epsilon a b a b a b b b and this is the clean closure. Clear? Next, positive closure. Positive closure. Positive closure. Positive closure. It is a set of all strings over the given alphabet excluding epsilon. Excluding epsilon. It is the set of all strings over the given alphabet, excluding epsilon or null string. For example, sigma is a and b. Sigma plus equal to A, B, A, B, B, A, and so on. This is the positive closure. This is the positive closure. The relationship between positive closure and clean closure is, note, union epsilon, union epsilon. This one is plus. Okay? This is the relationship between clean closure and positive closure. Clear? Clear? Very good. Next, language. Next, languages. Language. What is language? What is language? A set of strings over the given alphabet is known as language. A set of strings over the given alphabet is called language. Is called language. Okay? Is called language. For example, language can be finite or infinite, empty or non-empty. For example, sigma is A comma B, language A, B, A, B, B. This is the language, and this is finite language, finite non-empty language. Finite non-empty language. Clear? Next one is epsilon. This is finite empty language. This is finite and empty language. Phi, this is empty language. Sorry, this is not empty. This is not empty. Fine. This is finite language. Only epsilon is there. Epsilon is there. This is the finite language. There is only one string, that is epsilon. The length of this string is 0. Empty language. Next, epsilon A, B, A, B, B, A, and so on. This is the infinite language. This is the infinite language. Clear? This is the infinite language. Clear? Very good. Next, what is grammar? What is grammar? Grammar is a set of rules to generate the string for a language. What is grammar? Set of rules. Set of rules to generate a string of a language. Set of rules. We will discuss in detail in further videos. Set of rules that generate a string for a language. It is denoted by capital G. It is denoted by capital G. It contains 4 tuples. It contains 4 tuples V, T, P, S. V, T, P, S. Where V is the number of variables. Where V is number of variables. T is number of terminals. We will discuss later in detail. P, number of productions. S is starting symbol. S is starting symbols. Clear? Clear? So these are the basic terminologies that are used in the theory of computation. What are the basic terminologies? First one is alphabet, string, substring, trivial substring, non-trivial substring, prefix, suffix, length of the string, power of the sigma. Clear? And clean closure, what is positive closure, what is language, what is grammar. Clear? In next video we will discuss finite automata.